There are a lot of different sorts of diseases that you would benefit from being able to introduce new sequences into the brain, and that's why if you look at that FDA approved list, you'll see AAV popping up a lot there because there are certain serotypes of AAV that have gotten the reputation for being able to access the central nervous system. And we work on metabolic diseases that have neurologic manifestations. And so we've worked with AAV to try and get that into the central nervous system. Some of the most advanced trials, they're actually putting the vector, directly into what's called the cerebrospinal fluid, and to get more readily get access to the brain. And the results from those clinical trials are encouraging right now. And then it's not exactly the brain; it's more like the neuromuscular junction. It's called that. It's the SMN protein that's missing in spinal muscular atrophy. That has been a huge success story, because these are kids that don't live, past the age of 10 months. They die of they don't get any milestones. They don't learn to sit up or roll over or anything like that, and they die of lung insufficiency. But it does require a high dose of AAV vector. That some of the problems are emerging from that, but there are probably thousands of kids that have been treated and saved with that now. So it's almost miraculous. So I expect that there will be more having an effect on neurologic manifestations, and I look forward to seeing data generated where we're actually getting gene engineering and targeted modifications in the brain to treat these different diseases.